Hello and welcome, and in this lecture we are going to start making our Chip 8 emulator. Now obviously, because the Chip 8 emulator is designed for emulating games, we are going to need to have a way to output pixels to the screen. So there's a nice little library called SDL, and this is a graphics library that allows you to create a window and basically draw pixels to it. It's exactly what we need. So in this lecture we're going to start making our very first Chip 8 project, and we will then link with the SDL library and also create our very own SDL window. So that's what we're going to cover here. There's some important things you need to note before starting this lecture. Firstly, I am going to be creating all build files manually throughout this entire course. So what is a build file? Well, for example, make files. So if you're using an IDE that compiles your project for you, it probably creates these make files for you. I'm going to be doing them manually, and I just want you to bear that in mind because I assume that you are perfectly comfortable with your IDE and working environment. You should know how to be able to link with libraries, and you should know how to change the include directories for headers. If you know all that, then you're going to be fine. Please follow this lecture. Right then, the very first thing we need to do is download the SDL library. So just search on Google SDL download. And you'll see this one from libsdl.org. Just click that. We do not want the runtime binaries because we're actually developing with SDL. So we want to go for the development libraries. Now I'm using the Mingu compiler throughout this entire course. You're perfectly able to use the Visual C++ compiler. That's absolutely no problem. But I'm going to get the Mingu one here. So I'm going to press save, and it will download the zip for me. And I'm going to open that, and I'm just going to extract this entire directory to the desktop. Excellent. Now that I have SDL downloaded, I'm going to open Visual Studio Code, which is the editor that I'm going to be using throughout this course. You're more than welcome to use any editor you like. So I'm going to go to my desktop, and I'm going to create a new folder called Chip 8. This will be our project folder, right? So I guess if you're using Visual Studio, just create a new project, call it Chip 8. And I'm going to go File, Open Folder. I'm going to select Chip 8 and select Folder. Okay, brilliant. So there's a few things we need in here. Your IDE has probably created these things for you if you're using one. I'm going to create a bin directory, which will be where the executable binaries end up outputted. And I create a build directory for the object files. And I create an include directory where all our includes will go. And I'm going to create a source directory where our source files will go. Excellent. Now inside source, I'm going to create a file called main.c. So if you're using an IDE right now, please create a main file. And I'm just going to go include stdio.h, and then I'm going to go integer main integer argc char argv. So this will just be our main function. You know, I assume you guys know C because this is not a beginner's programmers course. This is a beginner's emulation course. Okay. So now in here we're just going to go printf hello world, and that'll be it. Okay. This is just, you know, for the hello world program just to get us started, and then we'll build on it. So I'm also going to create a make file to actually compile our project. So I'm just going to go here and create a new make file. And if you're using an IDE that automatically builds your project for you, it will generate this for you most likely. So you only need to worry about this if you're doing this manually like I am with a Mingu compiler or something. So here we go, all. And we tab here. This is a tab-based language. I recommend reading up on makefiles if you do wish to do this manually like I'm doing. Otherwise, rely on your IDE's automatic building. That's completely fine too. And here I'm just going to go gcc main.c-o ./bin/main, and also by here just do ./source. So all this is going to do, it's going to compile our main.c file, and it's going to output the executable in the bin directory. That is it. So the make file is essentially just an automated building script. It just builds our entire project. You know, if you use IDEs, they generally make these for you. So when you, in your IDE, when you press create new file or whatever, create new source file, it'll update the make file automatically for you. But because I'm doing it manually, you know, I have to do this from scratch. So you really don't have to worry about this if you are using an IDE that creates these for you. Just do your normal right click, create new file, and that'll be absolutely fine. It'll create this make file for you, okay? So here at the top here, I'm going to create a variable in the make file called includes. And this is just going to be equal to -i./include. Okay, and then here I'm just going to go $includes. So in case this isn't self-explanatory, I'll explain it. This here is replaced with its value. So it gets replaced with that, okay? And for those familiar with using GCC on the command line, this just specifies that the include directory is here. Use this one as an include directory as well as the standard include directory. That's all that says. Okay, cool. So here I'm also going to go flags equals -g. Now -g enables debugging symbols. So if we run into any problems, we can debug the application. I recommend enabling debugging symbols on your IDE if you're not doing this manually like I am. Right, so we put in the flags there just like that. And that is it for the actual basic setup stage, and we can now actually start integrating the SDL library. So let's first just check that this all compiles fine. So I'm just going to go to my terminal here, my command prompt, and I'm just going to go mingu32 -make. I'm going to press enter. We can see it runs that command, and if we now cd into the bin directory, we can see main.exe. If I run main.exe, we see hello world is outputted. So yeah, okay, we're now definitely ready to start integrating SDL. So let's do that now. So the first thing I need you to do, I need you to go to your desktop, and you'll see the SDL library that we saved earlier. Just click on that, and now you need to select the right one. The i686 will work fine for me. I'm compiling for 32-bit applications, not 64-bit applications. So this is the right one for me. I do suggest for this tutorial you compile 32-bit applications rather than 64-bit, but I'll leave that choice to you. So I'm going to open up this one, and there's a few things we need, so I'm going to go over this now. We need to go into the include directory and copy this one over to ours. We need to go into the lib directory, copy all of these A files, and we need to go into the bin directory and copy sdl2.dll. So that reminds me, before we continue, let's just create a lib folder here as well, and our libraries will go there. Now, before I do anything else, for you guys using the IDEs with the automatic build process, essentially what you need to do now, you need to configure your IDE to look here for includes, okay? To look here for includes, not the SDL2, but the actual include bit here, right? You need to configure your IDE to look for lib in here, this lib directory. And finally, when you compile your project, you need to ensure that when you run your binary, SDL2 is in the working directory. SDL2.dll is in the working directory. So I'm letting you guys know that, because if your IDE is automatic building, then this would be the way you would do it, okay? So look up how to do that with your IDE, how to select which libraries to run and which include to use. Once you've done that, you're fine. But for those of you doing it manually, keep watching. And for those of you that aren't doing it manually, we are still going to write a little bit of SDL code, so keep watching as well. Okay, let's begin. So we're going to go into the include here. We're going to copy SDL2. We're going to go into our directory here and paste it into our include. Okay, good. So if we now look here, we now have the SDL2 include. All of the header files are now there, which is great because that allows us to talk to the SDL library. So here we need the actual library code. So we're going to go back to the desktop. We're going to go into lib, copy all of these. And again, i686 is for the 32-bit version of SDL, okay? So we're going to copy all of those, the A files, back to the desktop, back to chip 8. We're going to paste it into our lib directory. We're going to go back, SDL2, i686, and the last one we need is the SDL2.dll, which is the dynamic link library for SDL, for the SDL library. We're going to go into chip 8, into bin. We're going to paste that in there. Okay, so we now have all the files we need. I now need to adjust the make file so that it can look for this library. So before we do that, do remember that if you have an IDE that automatically builds, essentially you just need to configure your IDE to link with SDL and resolve the headers in the SDL's include directory, okay? So you do that instead of this, essentially. But if you're going down the manual route like me, this is what you do. Alright, so let's carry on. So what you do is you go -L./lib. Now this tells the GCC compiler to look for libraries in the lib directory here. Okay, so the next step is to resolve the Mingu32 library. You do not have to do this if you are not using the Mingu compiler. Okay, if you're using Microsoft's C++ compiler, you don't need to do this bit. So we do -L Mingu32. Okay. Now the next bit you will need to do if you're doing this manually, even if you don't use the Mingu compiler. Again, if you're using the IDE, configure it to link with SDL using your IDE. Okay. But this is how you do it manually. So we do -L SDL2 main. Okay. -L SDL2. That's all you need to do. And now we're going to run the make command to check that this works. And for those of you with a IDE that does this for you, just press compile and run. Just check this works. What you've done has worked. So we just go Mingu32-make, and this is how I build it. And I can see that builds fine. Okay, good. So for you, with the IDE, you'll press compile and run. For me, this is how I compile. Right, okay, that's good. So now what we're going to do is we're going to start writing C code that uses the SDL library. Okay, so back to the main.c file then. I am going to include the SDL2 header file. Okay, I am then going to go into here and do SDL init. And I'm going to go SDL_init_ everything. So that'll initialize everything to do with SDL. And we can check for errors here, but I won't do it here because this is just the first tutorial, right? Okay, so what we are now going to do is we're going to create a window. So I just wanted to go SDL_window * because this is a pointer. And we're going to call it window equals SDL create window. Okay, and we can see it asks for a title, so we're just going to call it chip 8 window. And ideally you would use definitions here, define the title in some header somewhere, but this is just to teach you and get you started, right? So here will be the window position, so you can set that to whatever you like, but if you want it to be a default, then you can use SDL_window pos undefined. Okay, SDL window pos undefined. Okay, so you do that for both the X and Y if you don't want to set it. So now comes the width. The chip 8 display is 64 by 32 pixels, so we're going to use 640 pixels by 320 pixels and we'll scale it up. The reason for that is because on a modern desktop screen, 64 by 32 pixels is very small. So it makes sense to scale it up. So we are now going to use SDL window shown for the flags. Now just get rid of this bracket at the bottom there, and you can right click and format document. I'm not sure if you can do it in your IDE, but you can do it in Visual Studio Code here. So we've now created a window here, right? So all I want to do now is at the bottom here, let's just go SDL_destroy window, and we're going to pass in the window here. Okay. Now we're going to compile that and run it. And we can see that when we run it, it pops up a window and closes it instantly. Well, that's because there's nothing pausing the window here, right? It literally creates it and destroys it instantly. Creates it, outputs hello world, then destroys it. So I'm going to do a while one loop here so that the program never ends. I'm going to compile and run that again. And we can see now this is our window, right? Okay. So we're going to draw pixels to this window. Okay, so we're now going to create a renderer which will allow us to draw to the window, and we're also going to pull events. SDL gives you events for like key presses, if they press the close button, and it also allows you to render to the screen. So we're going to be processing all of that now. So what we do to create the renderer, firstly let's get rid of this hello world because we don't need it anymore. We go SDL renderer asterisk, so we're creating a renderer now, right? We'll call the variable renderer, and we just do SDL create renderer, and it expects a window, an index, and some flags. So let's pass in the window. The index will be -1, and the flags will be SDL underscore texture access underscore target, and then put a semicolon at the end. So the renderer will be used for drawing pixels to the screen. So we now need to create an infinite loop. So just go while one, and this will be an infinite loop, and we'll break out of it when we get a quit event. Basically, SDL library passes events to you, such as key presses and so on. So we'll handle all that later, but let's just focus on the renderer for now. So create an infinite loop like I've done here, and we're going to say SDL underscore set render draw color, and we're going to pass in our renderer. We're going to pass in a red color, which will be 0, a green color, which will be 0, a blue color, which will be 0, and an alpha, which will be 0. So this is the color black. We're using red, green, and blue colors here to make up a final color. Look at RGB if you are confused. We are now going to clear the screen, so I just want you to go SDL underscore render clear and pass in the renderer. So what this will do, this will set the render draw color to black, and then we'll paint over the entire screen with the color black, because all of our render functions rely on the draw color here. Okay, let's now draw a white rectangle. Just go SDL underscore rect R. This is a rectangle. We're going to set the X to 0, we're going to set the Y to 0, we're going to set the width to 40, and we're going to set the height to 40. So this will draw a rectangle at X coordinate 0, Y coordinate 0, that is 40 in width and 40 in height. I now want you to change the render draw color. So above SDL rect, let's just say SDL set render draw color, renderer, 255 for red, 255 for green, 255 for blue, and 0 for alpha. Why do we change the draw color? Because we don't want to draw a black rectangle on a black background. You're not going to see anything. Now we do SDL underscore render draw rect, and we pass in our renderer and the address of our SDL rect. So this should be self-explanatory. This draws the rectangle to the screen. There's one more thing we need to do. We need to present our changes. To do this, you simply go SDL underscore render present, and then we pass in our renderer. Okay, you're now ready to compile and run this. I'm going to use Mingu 32-make. You guys should press compile on your IDE if you have not done this manually like me. I'm now going to cd into the bin directory and run main.exe, and I can see that my chip8 window now draws a rectangle to the screen. You'll notice you can't really move this window around or anything like this. This is simply because we are not handling the SDL events, which we'll do soon. So here we've drawn the pixels, but wouldn't it be nice to fill the entire box? Well, you can do that too. All you do is you change render draw rect to render fill rect. If you now go back and compile that again, run the program, you can now see a white box being filled in. Okay, let's now handle events gracefully. So all you do is you go up the top here, SDL underscore event, call it event, and then we're going to go while SDL poll event, and we're going to pass in the address of event. So what this will do, this will poll the SDL library for events, and when it returns an event, it will store it into our event here. Okay, so here we just say if event dot type equals SDL underscore quit, then go to out. Okay, so this will be our quit event. Basically, when you press the X on the window, this event will be fired. So this will go to our out label, which we haven't created yet. So just scroll down here, and we're just going to put out by here, just above SDL destroy window. Now I know a lot of people think goto is evil. I do agree, but in the C language, I don't believe it is whatsoever. In C, you're required to handle all memory resources yourself, and this is perfectly appropriate. A break would be nice, but unfortunately that would just break me out of this while loop here and not the infinite one. If we now compile and run that again, we can now see that works fine, and this time we can move the window without causing the program not to respond. Why? Because we're handling the events. SDL events also allow you to handle things such as mouse clicks, keyboard events, and we will be using the keyboard event later on in this course. I hope you've enjoyed these course previews. To purchase the course, please use the link in the video description. Every course purchase allows me to make more content and keep bringing value to you.